Hello everyone, welcome to next video tutorial on circular linked list with header node. In the previous video, I have explained the circular linked list. In today, I'm going to start with the how to represent a circular linked list with header node. So initially, the name itself indicate the header node that always appears at the beginning. Even though I have added any new node at the beginning of the first node, the head remains same at the its position. It always the first node in the given linked list. In this example, inserting the element from the front node. So this is the temp node which I have created that will be added at the beginning. So earlier 20 is the first node. Uh, then after inserting this temp node, this becomes the first node after head node. Then last pointer link will be remain same as the it contains last pointer link address always holds the head node. Okay. Then temp equal to get node. So this node is created. Temp order info is 60. The item is inserted. Then first equal to head pointer link. So this first obtain the first node address. First equal to head pointer link. Now this link has to be removed. In this place, what you have to call? We have to call this temp node and place in between this. So how to do this? Head pointer link equal to temp. Then temp pointer link equal to first. Then only this command sit in between head and first. This link has been removed. Then at the end, by default, return head. Okay. Then next is circular linked list with header node. Inserting the element from the rear end. Not you have to remove this front. Make use of rear end. Okay. Insert from the rear end. So in order to insert the element from the rear end, first I need the address of the last node. First I have to get this address of the last node. Then only I can insert the temp node to 8. I can attach temp node to 8. So not to get the last node, initially I'm making use of the current node as a variable which hold as a first variable like head pointer link. Head pointer link. It contain the first node. Or you can say instead of taking the first node directly we take current, so you can save the time like assigning it first, copying that first to current. Instead of that, directly make use of current here. Okay, first create the temp node which I'm going to attach at the end of the circular linked list. And earlier this last node contains the address of first node. We have to remove this. In place of that, I have to provide the link from here to where the temp pointer link equal to head. That become the last node. Okay. Then we'll see step by step. Temp equal to get node. This node is created. Then temp pointer inform equal to item. The 40 is inserted. Then current equal to head pointer link that obtain the first node. And we have to keep track until it reaches to the last node. How to check it? Earlier, this temp always holds the address of head, so that the last node should not reaches to the head. Until that you have to perform the operation. So this current become the last node before adding temp. So while current pointer link not equal to head, so current earlier, is it equal to head? No. Is it equal to head? No. Then keep on increment. Current equal to current pointer link. Once it reaches to the head at this place, it reaches to the head, so that you have to stop the iteration. We have got the current node as the last node now. Then once we get, then what we have to perform? Then uh, temp pointer link equal to head. Temp pointer link equal to head. This link has been removed and we are connected to this node. Then return head, and this link also provided current pointer link equal to temp. Current pointer link equal to temp. That also connected. This one and this one newly established, and by default we have to return head. Okay. Only two steps you have to remember. One is providing this link and remove this link, and provide the new link from temp to head. This will be provided from these steps. Then next step is delete from the circular linked list by using the header node. Delete front, we can say. Okay, delete front node. This front node means we cannot delete head, we have to delete the first. Head remains same, we have to delete this first. Then this first node after deleting this second node becomes a first node. Okay. For that, whenever delete for the element, always check for is it an empty list. If head pointer link equal to head means only head node is there, by default no other nodes are there, it becomes empty, then return head. Okay. uh, then case 2, list with more than one element, like this contain more than one element. If I'm delete this first node, this second becomes the first node, and you have to provide the link from here to where, head to. Head pointer link is earlier pointed to first, now it become head pointer link to second. Okay. See, it's for first case. Then first equal to head pointer link, first equal to head pointer link, second equal to first pointer link. This one established. Then head pointer link equal to second, this head pointer link is second. Then delete the item, first will be deleted, free first, return head. Return head will be given as useful, return head will be done. Very simple. Okay. Then delete from the rear end. I have to delete this rear end. For that, we required the previous one. Why we required previous? If I delete this last node, then this address from last pointer link provided to head will be left as it is. We can't keep it. We can't left it as it is. We have to delete that. Provide the connection from this node to the head. For that operation, we required previous variable also. We do not cannot take directly. For that, consider the previous will be from the head only. Okay. For that, and after that, we need to provide the connection. So first check that the list is empty or not. Declare previous and current node. Then current equal to head pointer link. First node I have taken, current equal to head pointer link. Then previous equal to head, this previous becomes head node now. When this becomes first, this becomes the previous. Then we have to reach until the last node by making use of this node. You have to reach until the this current reaches to, if current not equal to head, until that you have to check the condition. So we came to the last node. Then delete the current pointer info. This whatever the information there in current, this will be deleted. Then free current, previous pointer link equal to head, this previous pointer link equal to head. Then return head, always we return head at the beginning node, so return head as it is. Okay. So these are concepts we have seen in today's video. The next video I'm going to start with the doubly linked list. Okay. Thank you. Go through the video, and the international class I'm going to solve the queries.